Hi everyone, good afternoon. I'm N.S. Natesh, working as Assistant Professor in the Department of Mechanical Engineering, Savita Engineering College. In today's topic, we're going to discuss about friction welding. Okay, okay, let's see about what is friction welding, principle of friction welding, working, types, application, advantages and disadvantages. What is friction welding? Friction welding is a solid state welding process. Solid state welding are those welding process in which no external heat is applied or no molten or plastic state involves. In this type of welding, welding occurs due to external pressure applied into the solid state. In friction welding process, both the plates or workpieces to be joined are either in rotating or moving relative to one another. This relative movement produces friction which displaces material plastically on contact surface. A high pressure force applied till the completion of weld. This welding is used to join steel bar tubes up to 100 mm diameter. What is the friction of what is the principle of friction welding? Friction welding works on the basic principle of friction. In this welding process, the friction is used to generate heat at the interference surface. This heat is further used to join two workpieces by applying external pressure at the surface of workpiece. In this welding process, the friction is applied until the plastic formation temperature is achieved. It is normally 900 to 1300 degree centigrade for steel. After this heating phase, a uniformly increasing pressure force is applied until both metal workpieces makes a permanent joint. This joint is created due to thermomechanical treatment at the contact surface. So let's see in diagram. So this is the rotating workpiece and this is the non-rotating workpiece. Okay, it is driven by motor. Okay, and this workpiece keeps on rotating and this keeps on fixed. Okay, so due to the rotation and application of pressure, both the workpieces are held together. Okay, in this third step there creates a upset due to the rotation and application of pressure towards the non-rotating workpiece. There creates a upset. Okay, upset is created at this point, so there creates a upset is nothing but both the workpieces are welded stick together. And further on the step 4 there creates a permanent upset that is called as permanent weld. Okay, in the fourth step the rotating workpiece is stopped and only high pressure is given towards the non-rotating workpiece, and therefore it creates a upset. Okay, that is it creates a permanent weld at this point. So both the workpieces are held together and stick together permanently at the step 4. Okay, so these are the 4 steps. Okay, due to the friction it creates heat. Okay, due to the heat both the workpieces are melted and both are welded together, and due to the further application of increasing pressure both are welded permanently. Let's see the working. First, both the workpieces are prepared for smooth square surface. One of them is mounted on a rotor driven chuck and other one remains stationary. The rotor allows rotating at high speed, thus it makes a rotate mounted workpiece. A little pressure force is applied on the stationary workpiece which permits cleaning the surface by burnishing action. Now a high pressure force is applied to the stationary workpiece which forces it towards the rotating workpiece and generates a high friction force. This friction generates heat at the contact surface. It is applied until the plastic forming temperature is achieved. The temperature has reached the desired limit, the rotor is stopped, and pressure force is applied increasingly until the whole weld is formed. This welding is used to weld those metals and alloys which cannot be welded by other metal. Okay, which cannot be welded by other metal. So in the diagram, okay, at the step 3 the rotation is stopped, and at the step 4 only the increasing pressure is given. Okay, so it means Upset is created at the step 3, and a permanent upset, that is permanent weld, is made at the step 4 only because of the high pressure. Okay. There are two types of friction welding. One is continuous induced friction welding and another is inertia friction welding. What is continuous induced friction welding? This welding is same as we discussed. In this welding process, the rotor is connected with the band brake. This is called as a band brake, and the friction crosses the limit of plastic temperature. Okay, what is the plastic temperature for steel? We have discussed here 900 to 1000 degree centigrade. So when it is reached, the band brake comes into action, which stops the rotor. Okay, so the rotating workpiece gets stopped, but the pressure applied on the workpiece keeps on increasing until the weld is formed. Okay, so the rotor is stopped and the rotating workpiece stops, and but the pressure is continuously applied on the stationary workpiece for the weld formation. This is the permanent weld formation. What is inertia friction welding? In this type of friction welding, the band brake is replaced by engine flywheel and shaft flywheel. These flywheels connect chuck to the motor. In the starting of the welding, both flywheels are connected with one another. When the speed or friction reaches its limit, the engine flywheel is separated from the shaft flywheel. Shaft flywheel has low moment of inertia, which stops without application of brake. The pressure force is continuously applied to the workpiece. That is stationary workpiece. Stationary is nothing but it is a fixed workpiece. It does not rotate. Okay. Continuously applied to the workpiece until the weld is formed. Until the permanent weld is formed. Okay. Permanent weld is formed between here. So both the workpieces can be joined together. What are the advantages? It is environmental friendly process without generation of smoke, etc. Narrow heat affected zone, so no change in properties of heat sensitive material. No filler metal is required. Welding strength is strong in most cases. Easily automated, high welding speed, high efficiency of weld, wide variety of metal can be welded by this process. There are few disadvantages. Okay, this is mostly used only for round bars of same cross section. Non-forgeable material cannot be welded. Preparation of workpiece is more critical. High setup cost. Joint design is limited. Few applications of friction welding are they are used for welding tubes and shafts. It is mostly used in aerospace, automobile, marine, and oil industries. Gears, axle tube, valves, driveline, etc. components are made by friction welding. It is used to replace forging or casting assembly. Hydraulic piston rod, truck roller, bushers, etc. are joined by friction welding. Used in electric industries for welding copper and aluminum equipment. Used in pump for welding pump shaft. Gear levers, drill bits, connecting rod, etc. are welded by friction welding. So after finishing seeing this video link, you can click this video link and open the real-time application of friction welding. I will attach this PPT and you can go through this PPT and click this video link for seeing the real-time application of friction welding video. Thank you everyone.